Alright, so moving right along, we want to look at some examples where we are applying these equality tools. And the process is that as I'm solving these equations, um, I'm gonna discuss which equality tools we're utilizing. All right, so we'll begin with the first example. This one's not fairly difficult. It's a one-step equation. So we have x minus 4 is equal to 10. So remember, now we're dealing with a variable, and our variable is x, which can vary in values, but we're looking for a distinct value that will make this equality true. Alright, so we want the right hand side to be equal to the left hand side. So, for example, if I wanted to apply the switch right to left equality law, I could just say 10 is equal to x minus 4. So, this would be switch, oops, spelled switch wrong. Very embarrassing. So I can switch right to left. Now, this doesn't really change much, or nor does it really help us in solving the equation. There might be some instances where you would want to work one side over the other, but this is not the case. But I just wanted to illustrate that so that you can see it in an example, how that is applied. Now, next, ideally we would look to see if we can combine any like terms, but on the left hand side we have a variable and a constant, so we can't combine those. And on the right hand side we're just left with a constant. So what we want to do is solve for this variable x, and we have this constant, the minus 4, in our way. So we want to get the x by itself. So we must apply the add both sides equality solving tool. So add 4 to both sides. So remember, think of the scale, where if it's already balanced and I'm just adding objects of equal mass to both sides, the scale will remain balanced. So we did add both sides. Alright, so by adding both sides, we see that this value cancels out. Then we have 10 plus 4. And then 10 plus 4 gives us 14. So x is equal to 14. Now, to check that this equality holds, we will plug it back in. So it would be 14 minus 4 is equal to 10. 14 minus 4 gives us 10. 10 is equal to 10. Thus, the equality holds. So everything worked out perfectly fine. Now next, we'll look at the similar example, but instead we'll have a coefficient in front of our variable. So we have 2x minus 4 is equal to 10. So yet again, the goal is to isolate x. So we'll begin by adding both sides by 4. See that this cancels out, and we have 10 plus 4 is 14. So we added both sides. Now, this 2 is being multiplied to this x. So this could be viewed as 2 times x. So we want to get rid of this 2, and in order to have the variable by itself. So what we're going to apply next is the division equality tool. So we will divide both sides by 2 in order to get this to cancel out so that we have our x by itself. 14 divided by 2, that is 7. Now that we have solved for this, we can plug this guy back into our original equation and check our solution. So we have 2 times 7 minus 4 is equal to 10. 2 times 7 gives us 14 minus 4 is equal to 10. 14 minus 4 gives us 10 is equal to 10. Thus the equality holds. Perfect. So now we're going to look at some even more difficult examples where we have to utilize these solving tools.